Welcome to episode 8 of the Norton Nemeses 1500cc V8 rebuild. In this episode I'll be taking a closer look at the crankshaft, connecting rods, main bearings and a few other components. I've given the crankshaft and connecting rods a thorough clean, so now it's time to inspect the bearings, see if I can reuse any of them, or whether I need to buy new. I noticed one of the main bearings looks particularly bad. It looks like water damage to me, like corrosion. So this would definitely need to be replaced, which pretty much means I need to replace them all, because they're all pretty bad. This one's quite scored. But this one's particularly nice, which is strange. And this one's bad. So I'm going to replace all the main bearings, if I can find out what type they are and where to get them from. Although I first thought the big end bearings were good, at closer inspection you can see there's quite a lot of marking on the surface and indications of wear. So I need to go inside on my computer and try and research these bearings from the code on the back to find out where I can buy them from. I'll make a note of the codes and write down the big end diameters and main bearing diameters and the width of the shells and go inside and do some research online, and I find out the Suzuki GSX-R 750, the early model, shells seem to be the same size, so I managed to order one of each, one big end and one main, for trial. I compare the big end shells with the existing ones from the engine, and they're exactly the same in all dimensions except for the width. They seem to be machined down. The originals are 14mm and the new ones I've just bought are 17mm. When I look closely at the original big end shell, you can see the machining marks on the left, and on the right is the original big chamfer, so these have definitely been reduced in thickness. I now check the new main bearing shell. This looks exactly the same, and when I marry it up next to the old original one, it's identical, so I'm really pleased about that. I try it in the bottom bearing clamp, and it snaps straight in place lovely, so that's just perfect. With the main bearing shells confirmed as a like-for-like replacement, I go back to the connecting rods, undo the two bolts on one of the rods and remove the bottom cap so I can get the old shells out. The shells just slide out nicely. I offer up the new big end shell to the cap and it snaps in place perfectly and the little tang lines up just good. So that's just right. So now I can look at the side where it sticks out where it needs to be machined down. So it's just a case of making a little jig in my lathe and machine these down in width. I had a rummage around in my shed and found a piece of aluminium bar with a hole in the middle, roughly the right size, just needed a slight skim on the diameter for 34mm, which is what the crankshaft measured to exactly. So I take a light skim and then check it with my micrometer and it's just slightly up, so I take another cut and it's just perfect. I take a further skim off the diameter to allow some thickness for some PVC tape. With the diameter finished machined, I try a shell in place and it fits just nice. You can see the protrusion at the front, which I need to reduce in length, so I use that as a gauge length when I'm machining down the width of the new shells. So now the shell fits on and it's flush at the front. I then stick some PVC tape on the diameter to protect the surface of the bearing shell. I then offer up the shells to the jig, making sure the tangs are facing the chuck. Then clamp in place with a Ghibli clip. With the bearings in place on the fixture clamped securely with a clip, I can now face off the front surface nicely. I keep taking cuts until the tool just clears the aluminium fixture in front. This means I'm at the correct length, 14mm. I carefully remove the bearings from the fixture and use my scraper to deburr the edge where it's been machined. This makes light work of removing the soft metal. I trial fit the machined bearing into the conrod cap and it snaps in nicely, and it's now the correct width for the conrod. That looks much better. Well, I'm really pleased with that. My little jig works quite well and the bearing's now the right width. So now I'm going to measure the crankshaft journals to make sure they're all the same size and I can order the new bearings. The crankshaft appears to be in near perfect condition. The journals are really smooth and shiny and there's no ridges to feel. So let's get the micrometer on them and see what size they are. The big end's are 34mm diameter and the mains are 32, so I work out the imperial equivalent because my micrometers are imperial. I set the micrometer up to a nominal size of 34mm in its imperial equivalent, then offer it up to the crankshaft expecting it to slide over loosely, and it doesn't, it slides over just right, indicating this crankshaft web's not worn at all, which is really amazing really considering how bad the bearings were. I check the next bearing and big end bearing surface and it's just the same. And the third one, that's all good. And the fourth one. So I'm really pleased with that. That's a really good indication. So I can order the standard shells to fit this crankshaft now. With the big ends checked good, I can now check the main bearings. So I reset the micrometer to 32mm and offer it up to the crankshaft, and that also slides over nicely, indicating that the mains aren't worn either. So overall, I'm really pleased with this crankshaft. It appears to be in really good serviceable condition. The next thing I want to do is check the big end clearance using some plastic gauge. I break off and stick a thin piece onto the crankshaft web using a piece of tape to hold it in place, then assemble the conrod over it, making sure I don't rock it backwards and forwards while I'm doing up the end bolts. With the big end cap removed, you can see the plastic gauge is squashed flat, and what you do now is use a special gauge to measure the width of the flat. This tells you the clearance of the big end in millimetres. And this one's 0.05mm, which is just under 0.02 of an inch, which is within specification. I checked the fit of the gudgeon pin into the little end bearing, and it's a nice sliding fit, so that's really good. I tick this rod as checked and place it down with the rest. With the new set of shells arrived, I've now got to repeat the process 8 times, putting the shells in my lathe, machining them down, checking the clearances, and assembling them back into the connecting rods, ready for the grand day when they'll be finally assembled back into a running engine. That's the third rod done. There's 3 done, 5 to go. With all the rods done, these are the old shells lined up in a row, so you can see the damage. Some of them are actually reasonable, but some are really bad. I'll put them in the box of parts that go with the bike. It's sort of a memory box. I can't progress any further with the bottom end because I'm waiting for the gear and the liners to turn up, so in the meantime I'll have a look at the cam covers. I've made up some blanking plugs that cover up the old water holes and also welded up some holes underneath where the breather system used to go onto. These will no longer be needed. The cylinder head cooling system will have one inlet port and one outlet port like a conventional engine, but I've managed to retain the original sealing plug that fits over the outlet port, but I've made some new manifolds to go on top out of aluminium to replace the steel gantries that were on there before. So there's one for each bank of cylinders. And here's the second one as well, completed to the same stage. I need to finalise what I'm doing with the rear exhaust manifold, because I might need to bolt it to the cylinder head before I bolt the head onto the engine, because the screws are virtually impossible to get to underneath. Compared with the front exhaust manifold that fits quite nicely to the engine, this one doesn't seem to, and may need a fair bit of work or even make a new whole system. So what I'm going to do first is take it into the garden and remove the wrapping. This is like a glass fibre matting, and if you do it inside, all the little particles come off and make you itch really bad. So I'm taking it out in the garden in the fresh air to do it safely. The glass fibre matting is held in place really tightly with some wire. So first of all I cut this to remove it, then I can gradually unwind it starting from the end, working it inwards. The glass fibre matting unwinds nicely now with the wire removed, revealing the exhaust system beneath. I glance down, there's a little beetle comes running across the patio. He's not very happy, he's trying to make a big escape. He's a fast runner. I continue with the unwrapping. It's quite complicated seeing where it's wrapped next, making sure you do it in the right order, but eventually I get it all off. I look up and 2 pigeons are looking down. There's a blackbird looking at the 2 pigeons. It's a bit of a stalemate really, and he flies past the back of him, and then the pigeon pecks the other pigeon. I guess that's the pecking order. With the last bit of wrap about to come off, it reveals what's hidden underneath. And here is the manifold. I'm not quite sure of this shape or design, but I guess it must have worked. And this is really odd here because these 2 pipes are deflecting gas in opposite directions, which is really strange. I wind up all the glass fibre insulating material into nice neat rolls because I might be able to reuse that later on. Then I pick up all the bits and head back to the house. I pass through the kitchen and Tracy's cooking some more cupcakes, which is really nice. We haven't had any for quite a while. And she's just finishing the mix, which is a lemon and sultana, which is just perfect. So we're just adding some extra bits to each of the cup. She's very particular on the amount of stuff you put in each one. They've got to be exactly the same. With the last few bits of mixture put into the cups, she puts them into the oven to cook. They take about 20 minutes, they don't take too long. The funny thing was, Tracy looked up and saw me holding this dirty old exhaust and glass fibre matting and said, "What are you doing in my kitchen with that? Get out straight away." But I couldn't resist trying to take a cake anyway. On second thoughts, maybe not. Back in the garage, Charlie Weaver's just seen the exhaust. It made him go red in the face and smoke came out of his ears. He's not impressed. When I was taking the bike apart, I noticed huge gaps between the cylinder head and the manifold, but I assumed it was because the gaskets were blown. But in fact it's not, it's because the flanges are out of square, by quite a lot. This will need a lot of work to sort out. The big question is, do I make a new one or try and repair the old one? Perhaps you should leave a comment and let me see what you all think. I got back in the garage just in time because I look out the window and it's absolutely pouring down with rain. I would have got really wet. I'm going to park the exhaust for a little while and have a look at the cam drive gears because one of them had excessive backlash that I need to deal with. The cam drive gear at the other end of the crankshaft is actually okay. This one's just nice. The teeth engage nicely with minimum backlash. There's no designed-in method of adjusting the cam gear engagement, so basically I need to remove the gear and have a look at the pivots to see if I can move the pivots. The pivot's got a bronze insert pressed into the aluminium engine, which makes me think it may have been adjusted in the past, maybe when they're setting the engine up, I don't know. But basically I'm going to pull this bronze bush out and make a new one with slightly eccentric centre that I can adjust to get the running clearance. To remove the bronze bush from the blind hole, I start tapping a thread in the centre and I was going to use a bolt to screw down and jack it out, but as I kept turning, it was lifting out the casing on its own, so that's just perfect, so I carried on. With the bronze bush out, I made up an aluminium bush as a temporary gauge that was loose fitting in the engine, so I can rotate it backwards and forwards and make sure I get the cam gear engagement just right before I commit to making the bronze one and pressing it in. So here's my aluminium one I knocked up quickly. That just drops in nicely, it's a nice push-in fit, and I can adjust it by turning it. I've made a little scratch line on there, so I know where it is relative to a dot on the crankcases that I can replicate with the bronze bush. With the temporary adjustable bush in place, I return the wheel into the centre and put the pivot shaft back in, pressing down firmly, and check that I can still rotate the gear. And it engages with the intermediate gear just nicely above it, so now I need to check that it engages with the crankshaft in the same fashion. I carefully lower the crankshaft down onto its main bearings and engage the gear, and it fits much nicer, virtually any play at all now. Just perfect, I'm really pleased with that. With the gears now meshing nicely, I machine up a phosphor bronze bush with similar dimensions to the aluminium bush, except larger on the OD so it's an interference fit in the aluminium casings. So first of all, I heat up the aluminium casing with my blowtorch to make it expand, so the bush is less of a tight fit to press in. And as it cools down, it'll grip it really tight, it won't move. I carefully line up prescribed marks and tap it in place with a drift. It's still quite tight even though I heated up the aluminium. As an added precaution, I drill and tap an M4 hole through the aluminium into the bronze bush and hold an M4 grub screw in place with some stop-tight thread locker. I don't want this bush moving at all while the engine's running. I replace the cam gear and tap in the pivot shaft in the centre. It's a nice press fit, which is good, because we don't want it moving. I do a final check on the grub screw just to make sure it's really tight, and it is, so that's good. And everything spins nicely, and it drives the intermediate gear nicely with no backlash. So now, I want to drop the crankshaft in and see if the backlash has gone. As I engage the gears, I can see immediately there's a big improvement, and it's just nice now. Both sides sound the same, so that's really good. I check on the outer casing, and it's already got an eccentric bush made, so all I had to do was rotate it very slightly, and it lined up perfect with the new position of my pivot shaft, and the screws screwed into the engine casing is just perfect, so I'm really pleased with that. With a couple of screws tightened, I check that the case fits onto the engine nicely, and it does. So I now look inside behind the back of the casing, check the gear still rotates freely, and it does nicely, so that's really good. And here you can see the profile of the casing matches nicely with the engine. Well, thanks for watching. I hope you enjoyed it. And I've just taken delivery of the new gear, so hopefully in the next video we can get the bottom end assembled.